Okay, so we're going to prove that for all sets A, B, and C, if A is a subset of B and B is a subset of C, then A must be a subset of C. So let's go ahead and start the proof. So we know we're going to assume A is a subset of B and B is a subset of C. So if we have A is a subset of B, this means that we have that for every x, if x is in A, this implies that x must be in B, right? And if we have B is a subset of C, this implies that for every x, if x is in B, this implies that x must be in C, right? So that's the definition of a subset, right? So we're going to let x be any element, and we're going to let x be an element of A, right? Well, by definition, for every x, if x is in A, that implies that x is in B, right? Because we know A is a subset of B. And if we know that x is in B for every x, right? That means x must be in C. And since we let x be any element, right? This implies that for every x, right? If x is in A, it implies that x is in C. And by definition, this implies that A must be a subset of C. And that is the proof, right? And of course, if we were to draw a diagram of what is going on here, it'd be even more clear, right? We have this big set C, then we have this smaller set B, and then we have this smaller set A, right? Notice that A is a subset of B, right? And every element possible in A is also in B. But if B is a complete subset of C, that means every element in B, including A, is also in C. So clearly, if you pick an X in A, right, and A is a subset of B and B is a subset of C, then that element here is going to be in C as well, right? And that's it.